Okay, so for this first part, we're going to be going over the isotope, the top part of this worksheet. So this is all about isotopes. So just a reminder, your isotopes are dealing with your protons and your neutrons. And you're using the logic or the idea that protons plus neutrons equal your mass number. Okay, so protons plus neutrons equals your mass number, and that is because they are the most massive subatomic particles, so we tend to rely on them for a lot of the average masses of these actual atoms, okay? All right, so, and from the notes from the other day, that would be the part where it was man. So we had an M, which is your mass number, minus A, your atomic number, which is your protons, okay, equals your N neutrons. Okay, so using that idea. But I like to think of it like this. It just makes it a little bit friendlier in my head. Use what you need to do. All right, so I'm going to go ahead and change to the next slide, which is the same thing. Just want to rearrange it. All right, so I have our periodic table here that we will refer to. I will take my time on number 3. I know I hit it probably during sync time if you've watched that recording already. But I will take my time on that, and that way you get an understanding of how to handle that one. I did not mean to put an ion on this page, but it's there, so we're going to deal with it. All right, so first row, we've got calcium, and that says 40. So I'm just going to kind of zoom in and scroll across. So we have calcium 40. And so for our nuclear symbol, remember, nuclear symbol is going to be your chemical symbol. So chem symbol, right? Chemical symbol, and you're going to have your mass number, and you're going to have your atomic number. And that's how we're going to be writing this nuclear symbol. Your isotope name, as you remember from the video that was recorded for Thursday's lesson, is just going to be your chemical name, a little dash, so that's not a negative sign, that's a dash, and then your mass number. Okay, so name hyphen mass number. Okay, and that's what we see here. So we have our chemical name, calcium. We have a nice little dash in the middle, and we have 40 written on the other side of it. I probably should not have wrote over that. My bad. There you go. All right, so we have a little dash in the middle. All right, so looking at what we've got, we're going to set up our nuclear symbol. So we have calcium, the chemical symbol according to your periodic table, and that's what you're going to be referring to if you're not familiar with them yet. But you see that we have a Ca. So we're going to write Ca, and then the top number is going to be our mass number. So remember, this is your mass number. So I gave that information already to you. When it's not given to you, you have to do a little bit of thinking with your number of neutrons and protons. And then your atomic number will also come from your periodic table, and that would be 20. The top number there was 20, okay? So we're going to put a 20 in the lower left-hand corner for your atomic number. There's nothing else that we need to write. That is your nuclear symbol for calcium 40. Now we can fill in atomic number. Atomic number, we put it down here. We got that from our periodic table, so that was 20. Our mass number, we were given, okay, which was this top number right here. So we're going to put 40. So that was given to us. And you can kind of always check that on the periodic table. You'll start noticing it's very, very close to what this decimal number right here is. It's usually off by like a decimal amount, okay? So it'll usually be close to this number. All right, and that's what the point of the lab is today on Friday. All right. So number of protons, we're going to use the idea of our atomic number. So that is the first box that I'm approaching. Number of protons, I'm going to put 20. Okay. Number of neutrons is going to be, we're going to take our mass number. We're going to take our mass number. We're going to subtract our protons. So that's that part where we were doing mass minus atomic number equals neutrons, right? So we're just using that idea right now. So we're going to do that, and you should be getting 20 for your neutrons. And then this last box that we've got is number of electrons. Well, since this is not an ion and it is neutral, we can assume A equals P equals E, just like on the first part of this homework. So we're going to put a 20 there. So that is the line for calcium 40. Okay, so now we've got the next line, the red box is number 2. We're given an atomic number, a mass number, and that's it. So what we can start with is we can go ahead and use this atomic number. I'm going to throw it into my protons box first. I know that it's 26. I can assume all of the ones up here, except for the one that says ion, is neutral. So I'm going to go ahead and also put that over here in my electrons box. I can solve for neutrons. So I can solve for my neutrons by taking my mass number again, subtracting the 26. I want to put arrows here so you know that I'm going to the right. So 56 minus 26 to get you 30 for your neutrons. Now I'm going to go ahead and go back to the left-hand side of this row. We can start filling in our stuff over here. So I'm going to take my periodic table. I'm going to look up who is atomic number 26. So looking at your periodic table, we find that atomic number 26 is iron. Okay, so we're going to go ahead and put iron. I'm going to put that dash, and then I'm going to use the mass number to define the isotope, 56. My nuclear symbol for this would then be my chemical symbol, which is Fe. That's one of the weirdo ones that doesn't match up. It stands for ferrous. So a lot of us have maybe heard that in some of your medicines and things like that. So iron is Fe. This top number is going to be my mass number, so the 56 will go up here. The lower number is my atomic number, so the 26 will go down here. And that's that second row. All right, so number 3 is the one that was not very fair, so I'll kind of use this blank area down here to help you fill that one in. Actually, I will save that for the very, very end, and that way it'll help us in our next part, which is the ions part. So I'm actually going to do number 4 next. Okay, so I'm going to number 4 right here. All right, so I'm given this symbol. We have 197 and 79. So what I'm going to do is I'm going to zoom in. I need to find AU on my periodic table. AU is gold. That's one to get used to. You're going to see that one a lot this year. Gold and silver. So AU is gold. So we can go ahead and start writing our isotope name. So we have gold. And I'm going to put that dash. And then we use our mass number to help name the isotope. So we have 197. So now we can proceed with the rest of these. And so atomic number is our next column. So I'm going to go ahead and use the bottom number right here, the 79. We'll write that in for atomic number. Oops, 79. Okay. I know automatically, so notice once I get my atomic number, I always go straight to my protons. Knock that one out. So this will be 79. And then I double check, does this have any kind of charge? No, so it's not an ion, so I know that I can also put 79 right here. Okay, but you might get in the habit of maybe saving electrons for last, and that's okay because that's what we're going to be doing for ions. So we have 79. So now we're going to figure out our mass number. So that was already given to you right here, the 197. So we will put 197 in this box. I'm going to use my mass number and number of protons to figure out my neutrons. So mass number minus protons to give me my number of neutrons, which is 118. Okay, so notice this is where you start seeing that those neutrons just kind of fill up the nucleus. All right, that's a big difference right there. So it's not like calcium. So when we're smaller atoms, they tend to be very similar. As we move down the periodic table, they start to have a bigger difference. All right, so we have 118, and then we look, we double check that charge thing, nothing, so we can put that 79 into this last box. Okay? All right, so that moves us to the next part of this little video lesson, which is going to be ions. So for ions, okay, kind of give us a clean screen here. So for ions, we have to now consider the fact that ions mean there's a difference in protons and electrons. Okay, so no, we're not really dealing with the neutrons as much. This first example, we're still dealing with the neutrons. This is kind of a more advanced question on that one, because you still have to solve for it. But down below, you can start relying. Actually, that's a lie. You're going to be dealing with all your different subatomic particles, but you determine an ion and the charge on an ion just from protons and electrons, if that makes sense. Okay? All right, so looking at our first example for that, so I'm doing number 3 above right here. So we have chlorine, 35 ions. So just to kind of finish up what we had done on the previous part of this video, we have our chlorine is our chemical symbol. So I'm just going to go ahead and write Cl. Okay, the top number is going to be my mass number, which is given to us in the name. So I'm going to put a 35 up here. My bottom number is my atomic number. So looking at the periodic table, I'm going to look it up. That is number 17. I'm going to put that down here. And now I did tell you the word ion. So that tells me we're going to have something that we're going to add at the very end right there. And it's going to be a charge. Okay, so we'll come back to that at the very end of this row. We're going to fill in what other information we have. So we have our atomic number, that was 17. We have a mass number, which was 35. You have your number of protons from this atomic number. And just on as a side note, let's just say you forgot that you had the mass number over here. Like, let's just say you forgot that that is the mass number, right? And you just had this blank box and you're like, oh my gosh, what am I supposed to do? Don't forget that you have the option to go the other direction in that little subtraction addition problem, okay? So you could also take your number of neutrons, 18, plus your number of protons, 17, and add them together to get that 35. So just know that you always have that option. But let's go back to our last step, which is now we're like, okay, so I noticed that this is not equal to that. So the fact that I have a difference in protons and electrons is what confirms this ion idea. But now we got to figure out what is the charge, what is the definition of that ion. So what you do, I'm going to kind of show you 2 different ways on this example, okay? So my preferred way, especially starting out, so most of you guys, this is the first time you're ever hearing about an ion, okay? What I recommend is use a little logic, all right? So you know that protons are positive. You know protons are positive. I have 17 positive protons. I have 18 electrons. Electrons are negative. I have only 17 positive things, and I have 18 negative things. Who do I have more of? Hopefully you said electrons. So I have more electrons. So that's your first question. Who do you have more of? Once you've answered that question, that tells you if I have more electrons, the symbol for my charge is going to be negative. So more electrons means negative. Now I would go back and I would figure out what is the difference between these 2 numbers. So the difference between 17 and 18 is 1. My charge is going to be a negative 1. Okay? So just a quick recap on what I just made you ask yourself. You say, do I have more protons or electrons? You have to ask yourself that first. And you have an option. If I have more protons, I'm going to make a little flow chart here. If I have more protons, then that means that I have a positive charge. If I have more electrons, then that means that I have a negative charge. So this first question is just to figure out, sorry, I'm kind of squeezing in there, just to figure out, do I have a positive charge or do I have a negative charge? Once you've done that, draw your charge out. So for ours, we found we had a negative charge. Now you can actually go to what is the difference? In quantity. So now you can deal with the number part. So that number part, for ours, we said 17 and 18. So it's really just taking your big number. So do your big minus the small number to figure out what is the difference between those. And that will be your number for your charge. So once you've established what your charge is, you're going to take that number and you're going to throw it. So I'm going to shrink this up, put that up in that corner. There we go. All right. So once you figure that out, now this number right here is going to come over to your nuclear symbol. Kind of traveled too far there, I think. And you're going to put a -1. And that's the charge. So really this answer for number 3 is Cl with a -1. And then you had the 35 above and the 17 below because I wanted the whole nuclear symbol. So that one's kind of an extra question, okay? So that was going to be kind of the way that you're going to handle this. The other way that you could have done it, if you don't like the logic reason, if it was just taking too long, you can also say, okay, I had 17 protons, I had 18 electrons. So what that means is that I'm going to say 17 plus a -18 is equal to, and if you type it in, you would then get that -1. So you can do it that way as well. And it still works for the ones on this bottom table. You're plugging in X for the number of electrons trying to figure it out. All right, so you can use algebra. There's nothing wrong with that, but I do recommend this way right here, the first way that I just showed you, and that way you understand the concept of an ion.